The fossils. So strange, they shouldn't exist. Evolution gave us the incredible, sprawling family tree of life on our planet. From the tiniest germ to the biggest whale, natural selection has produced some truly amazing creatures, each one sculpted to fit its world. But every now and then, the fossil record coughs up something that seems to break all the rules. A creature so bizarre, so alien, that it feels less like a product of nature and more like a hoax, or maybe a fever dream. These are the fossils that defy easy answers, the biological puzzles that challenge everything we thought we knew about life on Earth. They are the outcasts of the animal kingdom, the evolutionary experiments that went in directions so weird, they almost seem impossible. And yet, they are terrifyingly real, etched into stone as a testament to a time when the rulebook for life was still being written. Today, we're counting down the 10 most enigmatic creatures that science still struggles to fully comprehend. These are the fossils so strange. They probably shouldn't exist. Number 10. Coming in at number 10 is a creature that brings a pretty common nightmare to life. A bug the size of a small car. Meet Arthropleura. Picture a millipede. Now, imagine it's over 8 feet long, 2 feet wide, and weighs about 110 pounds. That's Arthropleura, the largest land-dwelling arthropod we've ever found. This absolute unit was scuttling across ancient forest floors between 345 to 295 million years ago, in what is now North America and Europe. Its sheer size is the first thing that just breaks your brain. For a long time, scientists figured its gigantism was thanks to the super high oxygen levels of the Carboniferous period. The atmosphere might have been up to 35% oxygen, compared to our 21% today. The thinking was, since arthropods breathe through simple tubes, more oxygen would let them get way bigger. But then, the largest Arthropleura fossil ever found was discovered in rocks from a time when oxygen levels were much lower than that peak, and maybe only a little higher than today's. That discovery threw a real wrench in the whole theory. So, how did it get so massive? Honestly, we're still not entirely sure. Scientists now think a nutrient-rich diet and a distinct lack of predators might have been the real keys to its growth. But the mystery doesn't stop there. What did this giant even eat? For years, paleontologists couldn't agree. Was it a terrifying predator, hunting early amphibians? Or was it a gentle giant? Some fossilized gut contents seem to settle the debate, showing plant material and suggesting it was an herbivore. But even that evidence is up for debate. Maybe the plant stuff just got fossilized next to the animal by accident. The current thinking leans toward it being a detritivore, like modern millipedes, munching on decaying plants, but probably not turning its nose up at a dead animal if it found one. Actual fossils of Arthropleura are incredibly rare, but its trackways are not. Giant tracks, some up to 20 inches wide, give us this ghostly impression of its journey across ancient landscapes. These tracks show it moved fast, navigating the open woodlands it called home, not the dense coal swamps people once imagined. Can you even imagine stumbling upon one of these in the wild? What sound would hundreds of legs make, scuttling through the undergrowth? Arthropleura is a chilling reminder that for a while, the biggest things on land weren't dinosaurs or mammals. They were bugs. Number 9. At number 9, we have a creature that takes an animal we all know and flips its evolutionary story completely upside down. We all know what a turtle is. That shell is its whole deal, a bony fortress it carries around. But where did that shell come from? For the answer, we have to look at a 210 million year old fossil named Progonocales. Found in Germany way back in the 1880s, Progonocales was, for over a century, the oldest turtle we knew of. At about a meter long, it definitely looked like a turtle. It had a fully formed shell, top and bottom. For a long time, this was a huge puzzle. It seemed to just pop into the fossil record as a completely formed turtle, with no obvious ancestors. But as we find more fossils, the picture is getting a little clearer. Other, even older relatives like Odontochelys and Papochelys are starting to fill in the gaps, showing us the step-by-step process of how the shell came to be. But when you look closer at Progonocales, it just gets weirder. First off, it couldn't pull its head into its shell like modern turtles. Its neck vertebrae just weren't built for it. To make up for this, its neck was covered in sharp, defensive spines, making it a much less appealing snack for the predators of the late Triassic. And the defenses didn't stop there. Its tail was unusually long and was also covered in spikes, ending in a small, bony club. This thing wasn't just a walking bunker, it was an armored, weaponized tank. Even stranger were its teeth. Modern turtles are famous for being toothless, using a sharp beak to slice up food. Progonocales, on the other hand, had small, peg-like teeth, but they were on the roof of its mouth. These weren't true teeth like ours, but tiny denticles on its palate, something completely alien to its modern relatives. The very existence of Progonocales is a critical yet deeply puzzling chapter in the evolution of one of the world's most unique animals. Its heavily built limbs suggest it lived on land, which challenges some ideas that turtles got their start in the water. So, we're left with an ancient turtle that couldn't hide in its shell, had a spiky club tail, and teeth on the roof of its mouth. It forces us to ask, what other strange features did the first turtles have that have now been lost to time? Number 8. Our number 8 entry isn't just one weird creature, but a fossil that created a decades-long mystery. It's a case of mistaken identity so huge it forced scientists to redraw a major branch on the tree of life. This is the story of Protomylician gateshousei. The story starts during one of the most important events in Earth's history, the Cambrian explosion, around 541 million years ago, when most major animal groups suddenly appeared in the fossil record. It was an explosion of evolutionary creativity that laid the groundwork for almost all animal life today. For decades, though, there was one glaring exception: the bryozoans. Bryozoans, or moss animals, are tiny colonial critters that build intricate underwater structures, like mini coral reefs. They are an entire phylum, a major branch of life. Yet, they seem to be totally missing from the Cambrian. The oldest known bryozoan was from the next geological period, the Ordovician. This made them a huge evolutionary puzzle. And then, scientists found Protomylician gateshousei. Discovered in 500-million-year-old rocks in Australia and China, these tiny branching fossils looked exactly like early bryozoans. Finally, the missing piece. Bryozoans were there during the Cambrian explosion after all. The mystery was solved. This idea made it into textbooks, and for years that was the story. Or so everyone thought. The trouble with fossils is you're often just looking at the hard parts. No one had ever seen the soft bits of Protomylician. But in 2023, a team of researchers looking at new fossils from China got an incredible surprise. Preserved inside the fossil's tiny chambers were the ghostly outlines of its soft parts. And they were not what anyone expected. Instead of the tentacles and complex gut of an animal, the fossils held simple, leaf-like structures. They realized they weren't looking at an animal at all. Protomylician was a plant, specifically a type of green algae. This revelation was a bombshell. In an instant, the oldest known bryozoan was wiped off the timeline. The entire phylum was once again the odd one out, the only major group of fossil animals with no record in the Cambrian explosion. Their origins are now a huge question mark again. This fossil is so strange because its story shows just how hard it is to interpret life from 500 million years ago. It shows how nature can arrive at the same solution from different directions, a process called convergent evolution. An ancient seaweed grew a skeleton that, for decades, perfectly mimicked an animal and fooled generations of scientists. Protomylician leaves us with a lingering question. What other animals in the fossil record might be hiding a secret identity? Number 7. Imagine you're a paleontologist. For over 100 years, you and your colleagues have been finding billions of tiny tooth-like fossils all over the world. They're in rocks from the late Cambrian to the end of the Triassic, a mind-boggling 300 million year span. These fossils, called conodont elements, are incredibly useful for dating rocks. There's just one problem. For 125 years, nobody had a clue what kind of creature they belonged to. This is the central mystery of our number 7 entry. The conodonts. These weren't just strange fossils, they were disembodied fossils. For over a century, scientists proposed every identity you can think of. Were they the teeth of an early fish? The grasping spines of a predatory worm? Some even suggested they belonged to plants. The elements themselves were clearly part of a complex feeding apparatus, but the body they were attached to was a complete ghost. The first big break came in the early 1980s, but it was another false alarm. A strange eel-like fossil was found with conodont elements inside it. Scientists thought they'd found it, but it turns out the elements were in its gut. It hadn't been the conodont animal, it had eaten the conodont animal. The real answer came shortly after, from a fossil deposit in Scotland. There, paleontologists found the faint impression of a soft-bodied eel-like creature, just a few centimeters long. And right in its head region was a full, intact set of conodont elements. At last, the owner of the mystery teeth had been found. But solving one mystery just created another. What was this thing? The animal had large eyes, fins, and V-shaped muscle blocks along its body, all features of early vertebrates. This placed conodonts within our own phylum, Chordata. They were our distant relatives. The evidence suggests they're primitive vertebrates, part of the same lineage that includes us. But the debate isn't fully settled. Some of their features seem more primitive than any living vertebrate. This has led to a fierce debate. Are conodonts true vertebrates, sitting at the base of our family tree, or are they a sister group that branched off just before vertebrates really got going? The conodont story is a perfect example of how much of the fossil record is just fragments. For 125 years, the conodont animal was a planet-spanning phantom, known only by its microscopic teeth. It was an eel-like creature that was a major player in the oceans for 300 million years, far longer than the dinosaurs. Yet its existence was a complete secret until just a few decades ago. It really makes you wonder how many other revolutionary creatures are hiding in plain sight, as a handful of tiny, baffling fossils. Number 6. Some fossils are strange because of their bizarre body plan. Others are strange because of the mystery they represent. But our number 6 entry is famous for one feature so outlandish that it looks like something straight out of a horror movie. This is Helicoprion, the fish with a buzzsaw in its jaw. Helicoprion was a shark-like fish that lived around 290 million years ago. For the longest time, the only fossils we had of it were these bizarre spirals of teeth. They're called tooth whorls, and they are one of the most iconic and puzzling objects in all of paleontology. A circular saw blade made of serrated daggers. Because the fish's cartilage skeleton rarely fossilized, all scientists had for over 100 years were these isolated tooth whorls, and nobody could agree on where on the animal they went. The proposed reconstructions got more and more wild. Did the whorl curl down from the lower jaw like some kind of weaponized trunk? Did it hang from the upper jaw? Some even suggested it was a defensive weapon on its back or tail. For decades, every drawing of Helicoprion was pure speculation. The mystery wasn't solved until 2013, when researchers got their hands on an amazing specimen from Idaho. Using a high-resolution CT scanner, they were able to digitally peer inside the rock and build the first ever 3D model of the Helicoprion's skull. And the reality was just as strange as any of the theories. The tooth whorl was lodged deep inside the lower jaw. It wasn't sticking out, it was an internal processing plant. As the animal grew, new, larger teeth were added at the back, pushing the older, smaller teeth forward and down into the spiral like a conveyor belt of daggers. So how did it use this thing? The scans gave us the answer. When Helicoprion closed its mouth, the tooth whorl would rotate backward, slicing its prey against the upper jaw. It was a brutally effective rolling and slicing mechanism, perfect for soft-bodied prey like squid. The scans also revealed another surprise. Helicoprion wasn't a true shark. It was more closely related to modern-day ratfish. Even with these discoveries, Helicoprion remains one of evolution's strangest creations. Growing up to 25 feet long, this was a top predator. Imagine a creature the size of a great white shark, but instead of rows of teeth, it has a spinning blade of death in its face. It's a testament to how far evolution will go in the arms race between predator and prey, and it took us over a century of guesswork and cutting-edge technology to finally figure it out. We are halfway through our list of baffling ancient creatures. If you're enjoying this journey into the weirdest corners of the fossil record, take a moment to hit that like button and subscribe for more explorations into the mysteries of our planet's past. Your support helps us create more content just like this. Now, let's get back to the countdown, because the fossils only get stranger from here. Number 5. At number 5, we have a creature so strange that it became the official state fossil of Illinois, not because people understood it, but because it was a complete and total enigma. Meet Tullimonstrum gregarium, better known as the Tully monster. First found in the 1950s by an amateur fossil hunter named Francis Tully, this 300-million-year-old creature has defied classification since day one. The fossils come from the Mason Creek fossil beds, a special place that preserved soft-bodied animals in stunning detail. And the details of the Tully monster are what make it so bizarre. It was a soft-bodied animal, usually about 6 inches long, with a body shaped like a torpedo. At the back, a triangular tail fin. So far, so normal. But then you get to the front. Sticking out from the top of its head was a rigid bar with 2 eyes on stalks at either end. And if that wasn't weird enough, extending from the front of its body was a long, flexible snout that ended in a claw-like appendage lined with tiny, sharp teeth. So, to recap, torpedo body, horizontal eye bar, and a long, toothy claw snout. What on earth is this thing? For over 60 years, scientists have been locked in a heated debate. Is it an invertebrate or a vertebrate? In 2016, a couple of studies made headlines claiming they'd solved the mystery. They argued the Tully monster was a vertebrate, a primitive fish related to modern lampreys. They pointed to structures they identified as a primitive backbone and gill pouches. If true, this was a huge deal. But the celebration didn't last long. Other paleontologists fired back, arguing that the so-called vertebrate features were misinterpreted. Then, new research in 2023, using advanced 3D imaging, strongly supported the invertebrate argument. This study found that the creature's chemistry and anatomical features just didn't line up with being a vertebrate, calling that hypothesis untenable. So if it's not a vertebrate, what is it? Some have suggested it's a weird kind of mollusk, or maybe an arthropod. The debate rages on. As of today, Tullimonstrum remains a creature without a phylum, a biological orphan. The Tully monster is the ultimate paleontological puzzle. It seems to be assembled from the spare parts of other animals, a chimera that doesn't fit neatly into any known category. It's a humbling reminder that even with perfectly preserved fossils, the history of life can be so strange that it remains fundamentally incomprehensible. The Tully monster is a question mark written in stone. Number 4. Our number 4 creature is a classic detective story. A tale of how 3 different animals, each one bizarre on its own, turned out to be a single, even more bizarre superpredator. This is the story of Anomalocaris, the abnormal shrimp. The story begins in the late 19th century with fossils from the famous Burgess Shale in Canada, a 508 million-year-old treasure trove. Paleontologists kept finding fossils of 3 very different, very strange organisms. First, there was what they thought was a shrimp's tail. It was spiny and segmented, and so unusual they named it Anomalocaris, meaning unlike other shrimp. The second fossil was a circular, flattened disc that looked like a jellyfish. It was named Patoya. And the third was a squishy body with no clear head or limbs, which they figured was some kind of sea cucumber. For decades, these 3 things, the weird shrimp part, the fossil jellyfish, and the mystery sponge, were all considered separate animals. It wasn't until the early 1980s that paleontologist Harry Whittington literally pieced the puzzle together. While excavating a new specimen, he found one of the Anomalocaris shrimp appendages attached to the head of one of the sea cucumbers. And then he found a Peytoia jellyfish right where its mouth should be. The shocking realization dawned on him. These were not three different animals. They were all parts of one giant creature. The shrimp was its feeding arm. The jellyfish was its circular mouth. And the sea cucumber was its body. The creature was officially named Anomalocaris, since that was the first name given to any of its parts. Once assembled, the true nature of Anomalocaris was revealed. It was the apex predator of the Cambrian seas. Growing up to 2 feet long, it was a giant for its time. It had 2 large compound eyes on stalks giving it excellent vision, and it propelled itself through the water using lobes along its sides. Anomalocaris would use its 2 spiny arms to grab prey, like hard-shelled trilobites, and bring them to its terrifying circular mouth, which would then crunch down and crush them. The story of Anomalocaris is a powerful lesson in how the fossil record can trick us. It's a cautionary tale about how our assumptions of what an animal should look like can lead us completely astray. It took nearly a century for scientists to assemble this Cambrian chimera and recognize it for what it was. The world's first great predator. A creature so strange, it had to be discovered 3 times. Number 3. Some fossils are so strange, their name is basically a warning. Our number 3 entry is a creature so mind-bending that the paleontologist who first described it named it hallucigenia, because its form was, in his words, dreamlike and bizarre. He was not exaggerating. Hallucigenia comes from the same 508 million-year-old Burgess shale as Anomalocaris. But where Anomalocaris was fearsome, hallucigenia was just weird. The original fossils showed a tiny, worm-like body, with a row of 7 pairs of long, sharp spines on one side, and a row of 7 flexible tentacles on the other. One end was a shapeless blob, the other was nothing. Faced with this biological nightmare, paleontologists had to try and make sense of it. The first attempt was logical, but completely wrong. Simon Conway Morris decided the sharp spines must be legs for walking on the seafloor, like stilts. The flimsy tentacles, he figured, were on its back, maybe passing food to a mouth nobody could find. The blob was the head. This reconstruction of a creature walking on rigid spikes became iconic, a poster child for the bizarre experiments of the Cambrian. It was an animal that made no sense. And that's because it was completely upside down and backward. The first clue came in the 1990s from similar fossils found in China. They showed that the tentacles actually came in pairs. A closer look at the original fossils confirmed it. The tentacles were actually legs, which meant the spines were for defense on its back. The discovery literally turned hallucigenia on its head. But that was only half the problem. Which end was the front? That shapeless blob was still assumed to be the head. It wasn't until 2015, using powerful electron microscopes, that researchers looked at the other end in incredible detail. And there they found it. A distinct head with a pair of simple eyes and a mouth, complete with a ring of teeth. The head blob was just decay fluids that had seeped out of the gut after it died. So, after decades of being upside down and backward, the true hallucigenia was finally revealed. A tiny, worm-like creature, walking on 10 pairs of claw-tipped legs, with a row of menacing defensive spines on its back. We now know it belongs to a group of ancient relatives of modern velvet worms and arthropods. Far from being an evolutionary dead end, it was part of the lineage that led to some of the most successful animal groups on the planet. The story of hallucigenia is maybe the most extreme case of paleontological misinterpretation in history. It was a fossil so alien that for years we couldn't even tell which way was up. Number 2. At number 2, we have a creature so unbelievable that when its reconstruction was first shown at a conference in 1972, the entire room of expert paleontologists burst into laughter, assuming it was a joke. It wasn't. This is Opabenia regalis. Like many of our entries, Opabenia comes from the 508 million-year-old Burgess Shale. And on a list of evolutionary oddballs, Opabinia is one of the all-time greats. It was a small, soft-bodied animal that swam along the Cambrian seafloor. It had a segmented body and a fan-shaped tail. But that's where any sense of normal ends. Let's start with the head. Opabinia had 5 eyes. Not 2, not 3, but 5 compound eyes on short stalks, giving it a 360-degree view. As if that wasn't enough, its mouth was on the underside of its head, and it faced backward. But the creature's most defining and frankly ridiculous feature was its proboscis. Sticking out from the front of its head was a long, flexible, vacuum cleaner-like nozzle, and at the end of this nozzle was a pincer-like claw, armed with spines. Opabinia likely used this bizarre contraption to hunt for prey in the mud, grabbing it with the claw and then maneuvering the long nozzle to deliver food to its backward-facing mouth. For a long time, Opabinia was considered the ultimate evolutionary enigma, a phylum of one. Its body plan was so alien it seemed to fit nowhere. It was held up as a prime example of the Cambrians' failed experiments. But we now know it's a stem group arthropod, an early cousin of insects and crustaceans, sitting on the evolutionary line just below its strange relative, Anomalocaris. And for decades, it was the only one of its kind. But in 2022, scientists confirmed that another strange fossil was a second Opabinid species. So it wasn't a total freak of nature. It was part of a small but distinct family of 5-eyed, nozzle-faced predators. Still, it's hard to overstate just how weird Opabinia is. The 5 eyes defy the bilateral symmetry that defines most animals. The frontal claw nozzle is a feeding tool unlike almost anything else that has ever evolved. It looks like a creature designed by a committee that never spoke to each other. It's a joke that evolution decided to play on paleontologists, and it is without a doubt one of the strangest fossils ever pulled from the earth. Number 1. We finally arrived at number 1. We've seen car-sized millipedes, buzzsaw-jawed fish, and 5-eyed creatures with clawed nozzles. But our top entry is a fossil so strange, so profoundly enigmatic, that it challenges the very definition of what it means to be an animal. This is Dickinsonia Mao. To understand Dickinsonia, we have to go back further than ever before, to the Ediacaran period, from about 635 to 541 million years ago. This was a world before the Cambrian explosion, populated by organisms so strange they're known as the Ediacaran biota. And Dickinsonia is their most famous and mysterious member. Fossils of Dickinsonia are impressions of a flat, oval-shaped quilted organism. Some were tiny, but others grew to be nearly 5 feet long. Its body was made of repeating, rib-like segments. And that's it. No head, no tail, no legs, no mouth, no gut. So what in the world was it? For decades, this was one of the greatest debates in paleontology. Was it a type of lichen or fungus? A giant single-celled amoeba? Or was it something else entirely? A member of a lost kingdom of life? The most tantalizing possibility was that Dickinsonia was one of the earliest animals. It could clearly move, leaving trace fossils behind as it crawled along the seafloor, likely absorbing nutrients from the microbial mats beneath it. But the lack of a mouth or gut was a huge problem. The mystery took a dramatic turn in 2018. Researchers in Russia found Dickinsonia fossils so well preserved they still had molecules of organic tissue. When they analyzed these molecules, they found the smoking gun they'd been looking for: cholesterol. Cholesterol is a fat molecule that is a hallmark of animal life. Plants and fungi use different fats. The discovery was hailed as the strongest evidence yet that this strange, quilted pancake was, in fact, an animal. But in science, no case is ever truly closed. Some scientists argue the cholesterol could be contamination from later organisms that seeped into the fossil, and even if it is an animal, what kind? It doesn't fit into any modern group. It has features that suggest it's a relative of most modern animals, including us, but its fundamental body plan is utterly alien. Dickinsonia. And the other Ediacaran creatures are from a chapter of life on Earth that is almost completely lost to us. They were life's first strange draft. Was Dickinsonia a pioneer at the very base of the animal family tree? Or was it a member of a completely separate, failed experiment in what it means to be a large, mobile organism? This is why Dickinsonia takes the top spot. It's not just a weird animal, it's a fossil that forces us to question the most fundamental categories we use to understand life. It exists on the blurry boundary between the familiar and the utterly unknowable, a ghostly impression from a world so strange, it might as well have been another planet. It is the strangest fossil on Earth because it asks the biggest question of all. What else is possible? Conclusion. From the giant, Arthropleura, to the definition defying Dickinsonia, the fossil record is a library of evolution's forgotten stories. These creatures are more than just bizarre footnotes. They're powerful reminders that the path of evolution was never a straight line. It was a chaotic, experimental, and often surreal journey. For every body plan that survived to the modern day, there were countless others that were too strange, too specialized, or maybe just too unlucky to make it. These fossils challenge our neat and tidy classifications and force us to confront the sheer, unbridled creativity of nature. They are puzzles made of stone, mysteries that scientists will continue to debate for decades. Each one is a window into a world where the rules of biology were still being written, and sometimes spectacularly broken. Which of these creatures do you think is the strangest? Are there any other baffling fossils you think should have been on this list? Let us know in the comments below. And if you enjoyed this exploration of life's greatest enigmas, don't forget to like and subscribe and hit the notification bell so you don't miss our next video. Thanks for watching.